similar to this here. This would be what's called a simple rational function, where you're going to have like a function over another function. Okay? It's basically everything that you've had up until this point, but the biggest thing is, whenever we've talked about it, is that you have, like, whenever we were multiplying and adding and subtracting and dividing and everything else, you had other things that were not just like an x or a number, things like that. You had like an x squared and x to the third or whatever. Okay, that's going to come tomorrow. Okay, where it's not going to be as what's called simple. It's simple because there's two asymptotes. There's two lines that you can't cross. There's going to be a horizontal one. There's going to be a vertical one. There's going to be, basically it's going to be sectioned off into like 4 quarters, okay, of the graph. Your graph is going to fit in 2 of those spots. Normally, for the most part, for everything today, there's one like in the top left, then there's going to be one in the bottom right. If there's one in the top right, then there's going to be one in the bottom left. Okay? Tomorrow it's going to be a little bit different, to where you can have like 3 sections, 4 sections, stuff like that. So whenever we graph, what's going to happen, like I said just a second ago, it's what it's called is a hyperbola. Okay? We're actually talking about more in depth with this right now with my pre-calc class, whenever we get into the conics stuff. With these are still functions. Okay? Whenever you get into pre-calc, what will happen is they won't be functions. That's why it's going to be called conics. Okay? Because they're not going to be functions. Here, everything is a function. You're going to have 2 asymptotes. You're going to have a vertical one and a horizontal one. And like I said, you're going to have 2 pieces of the graph. Of your functions that you're going to have 2 different types. Okay? You're going to have type 1, where it is very similar to what you have already done before, because you have the H, you have the A, you have the H, you have the K. Okay? You are accustomed to seeing things that look like this. Okay? Me personally, I think this is probably a little bit easier for students to graph, just because they know, hey, I've got to look. You're used to looking for the H value, you're used to looking for the K value, okay, and everything else. So your H, or whatever number is associated with your X value, okay, is always the opposite. So if it's a +4, then your asymptote would be a vertical asymptote at -4. Okay? Your Y asymptote, okay, or your horizontal asymptote, is just whatever your K value is. Okay? Your domain is always going to run up until you get to a certain spot in terms of if it's coming from like the bottom up or the top down or left to right, it will go from there to that asymptote. Okay, so let's just talk about the first type here. So first off, you have your asymptotes. You have your horizontal asymptote, and then you have your vertical asymptote. Okay, vertical asymptote is always going to be on your bottom side. So what does that mean? So your vertical asymptote is always going to come from here. So if it's x minus 1, what is your vertical asymptote? What can x not be? Positive 1 or negative 1? Positive 1. So my vertical asymptote is at x equal to 1. So then all I'm going to do is I'm going to have a vertical line here. There's my vertical asymptote. What is my horizontal asymptote? It's just going to be a positive 2. Okay, it's going to be exactly what it is. So it's going to be y equal to 2. Now, unless you have a graphing calculator, okay, which you can put this into a graphing calculator. The one thing I will tell you, if you're going to put it in a graphing calculator, then make sure that whenever you do this, if you're going to type this in, you're going to go to y equals, what you want to do is I would have a parenthesis and then go 3 divided by, and then run a parenthesis around x minus 1. And then close your parenthesis and then do plus 2. Okay? If you just try to type everything straight in and it looks something like this and you go 3 divided by x minus 1 plus 2, it's going to be all sorts of jacked up. Okay? Now, if you don't have one, okay, you've got to figure out where does this thing fall. If my x-intercept is at 1, okay, I'm going to have to basically plug and chug numbers into my function. Okay, what would be 2 intelligent numbers to go with? Okay, I don't want to go with 1. Why do I not want to go with 1? Because it's my asymptote. So 0 is probably a good spot. So probably 0 and... I would go 0 and 2. Well, but not for your x value. Okay? This is everything with your x value. Okay? So the reason why I would go with 0 and 2 for my x value is because then I put 1 on the left side and then I put 1 on the right side. Does that make sense? Okay. I will tell you, if you have a graphing calculator and you just type it in, you can look at it and be like, huh, there you go. And you can figure out where to draw it. Okay. The biggest thing with knowing where it goes, I'm not worried about how this thing looks. I'm worried about, do you have the right vertical asymptote? Do you have the right horizontal asymptote? If it crosses the x-axis, do you have the x-intercept right? And then, what's my domain and what's my range? Now, on your sheet, if you picked up one of the graphs, you see one that says oblique on there. That'll be for tomorrow. Every rational equation either has an oblique asymptote or a slant asymptote, or it has a horizontal. It can't have both. Okay? We'll talk more about that tomorrow. But if I plug in 0, okay, into my equation, and I have 3 over 0 minus 1 plus 2. So 3 divided by negative 1 plus 2. What's my y value? What's negative 3 plus 2? Negative 1. So that means I'm going to have a point here at 0, negative 1. I'm going to do the same thing again, but now I'm going to do it for the 2. So I'm going to go 3 over 2 minus 1 plus 2. So I have 3 divided by 1 plus 2. So what's my point at 2? 2, 5. So then I'm going to put a point at over 2 up to 5. That tells me where everything is. I can't not have I have a graph in the top right, I have a graph in the top left. So that just means it's going to look something like this here. So, my domain, what are all of my x values? My x values are always going to go from the left to the right. So, my domain goes from negative infinity to, what's my x asymptote? Negative 1 or positive 1? Positive 1. Okay. And then from negative 1 to positive infinity. What's my horizontal asymptote? Or what's my range, excuse me? From negative infinity to, where's my horizontal asymptote? 2. And then from 2 to positive infinity. I don't, because I think I heard that. There we go. So the range is going to go from bottom to top. Domain is going to go from left to right. Now, the one thing that is not on here is your x-intercept, okay, that I need to add for this. Anytime you have to do the x-intercept, okay, and it will be on your graphs, all I'm going to do is I'm going to set 0. I'm going to make y 0. And I'm going to go 3 over x minus 1 plus 2. And I'm going to solve for x. Okay, so if I do that, if I have 0 equal to 3 over x minus 1 plus 2, if I'm solving for x, I'm going to have negative 2 equals 3 over x minus 1. Now what? Cross multiply, right? So then I have negative 2x plus 2 equals 3. I'm going to go where I have a little bit more room, not much. Negative 2x is equal to 1. Divide by negative 2. So my x-intercept is at negative 1/2.